Thank you guys for the presentation. Excited to be following up such a wonderful group of panelists. I'm here today to talk about how we at the City of Austin are using crowdsourced data sources to help influence and improve our traffic management center operations. And at the very end, we'll get some information from my partner, Sean, who's a representative of one of our data vendors for how they're gathering and collecting that data for us. So to give you an idea of how we're using our system and how we're influencing with all of these different data sources, I thought it would be a great idea to step backwards and talk about what our system is as a whole. So we are a mobility management center. I know the industry term is often TMC. MMC we felt was more representative of all the different forms of transportation that we support and design for. In our current formation, we were expanded in 2016 with Kimley Horn as our prime consultant, and we are an active management center, meaning we are using real-time data to influence and respond to activity in our traffic system. So this includes about 200 miles of critical arterials with about 250 miles worth of fiber optic cable, so we can have that near 100% communication uptime with a multitude of our devices. We also use close to 200 cell modems to get to our peripheral areas of our system. But this is a real-time signal adjustment such that if you are unfortunately involved in a vehicular accident in our system, we can use our assets to be able to understand the complexity, severity of your crash and be able to respond to that with a signal adjustment, perhaps reaching out to our PIO office or other sort of social media avenues to be able to get information out to our travelers as quickly as possible. We also dispatch technicians based on feedback we're receiving from our system. We use an advanced traffic management system called KITS that gives us real-time information as far as the status of not only our signals, but other peripheral devices like our battery backup system and CCTVs, such that we're able to send technicians out and get those systems repaired if we're unfortunately not able to repair for them from a remote setting in our MMC. We're also involved in the event space, which I'll talk about here in the second half of our presentation. The City of Austin has the luxury of having a lot of different avenues to host a myriad of different events, all the way from CODA, hosting F1, which boasts, I think, nearly 450,000 people over the course of 3 days, all the way down to Austin FC. We're very excited to have our first professional soccer team here in the city. Lastly, we also are involved in emergency response. So large rainfall events, wind events, both for our municipality and for surrounding municipalities, we're able to gather our forces and get folks out into the field to get that infrastructure back up as quickly as we can. Just by the numbers, if we were going to break down our system and see how that would look, here's some quick baseball card style facts for y'all. We manage close to 1,100 active signals. If you bring in signals in design, it's closer to 1,400, which is pretty exciting. We're managing also nearly 650 traffic cameras. These are a host of different models that we're using. So we're able to log these in both at the intersection level as well as some high-rise cameras, which are really helpful to see progression across multiple signals. We also manage some dynamic message signs. So the buckle up messaging that you often see on freeways, we also have some inside of our city system. We also, in conjunction with that, manage school zone beacons. With the beginning of school for a lot of us, I know that this is at the forefront of our mind, and we're pretty excited to be able to host those not only for Austin ISD, but surrounding municipalities as well. One of the big data feeds that we use is a 311 call center with the city. So if a community member has a complaint either about a signal operation or would like to report some form of damage, they would call 311 and that ticket would get routed to us in the form of a citizen service request. And we manage to close to nearly 1,000 of those a month. You can see our hours of operation here. We are not a 24-hour facility. We have a technician available 24 hours a day for emergencies. If, for example, a PED pole is knocked down or a signal's in flash, we don't necessarily want folks waiting till 8 or 6 o'clock in the morning for us to be in office to get that repaired, in which case we can send that out overnight. But for the engineers on staff and other folks, those are our hours of operation. I've listed our staffing over here to the right as well. There are 3 managers, kind of a morning, afternoon, and evening manager, 2 operators to help us dispatch technicians as well as process those citizen service requests, and 1 data analyst to help us really dig into a lot of this good information provided by INRIX and other vendors so that we're able to evaluate and improve our signal operations. Lastly, I talked about moving out into the field and getting our hardware repaired if needed. We manage about 20 field technicians. That includes technicians both able to respond to what we consider trouble calls, which are emergency repairs and things related to that, as well as planned work. So if that's a flashing yellow arrow upgrade or something associated with that, we can use those techs as well. So talking about data feeds and how we're able to bring all of this information together, sometimes it does often feel like we're drinking out of a fire hose. You know, there's information every corner that you look at, but we really want to have an understanding of how we can succinctly process this data to have a better understanding of how to improve our system. So doing so, we utilize numerous disparate data feeds. Some examples here are shown on the screen. You'll see that top right picture is our ATSM software kits. So that's giving us information about our signals real time. Often, I know that picture is part of grainy, so I do apologize. We're able to see what signals are online, what signals we don't have communication to, and other important statuses such as conflict or police flash. That's picture at the very bottom where it says data tracker. That is our 311 system, so that we're able to integrate that with our asset management system built in-house. So we can not only track dispatches and get that back to 311 so they can get back to the appropriate community member, but we can also track inventory and other important metrics so that we have an understanding of where we stand with our hardware. The middle two photos are examples of both a public and private data feed. We're active on Twitter like many folks are. So at Austin Mobility is where we post information related to crashes to inform the public to perhaps find a different route before they leave their house, as well as major closures, special events, and things related to that. I often like to say if the marketing team is tweeting from this account, there's emojis and it's very cute. And if the engineers are, there are no emojis. So that's how you're able to tell what's in-house and what's not. Lastly, an internal data feed that we use is a CAD dispatch system related to our fire department. So we're able to see where they are being dispatched for emergency response. And although not information and events of that nature are always of interest to us. For example, an elevator rescue might not be exactly pertinent to your transportation network. It is helpful to see instances such as a traffic injury or a vehicle rescue so that we could know major responses and be able to adjust that accordingly. I mentioned earlier that the city has the luxury of having a lot of different special events. And just to name a few, like we've talked about, F1, Austin FC, UT football, and the like. We've extended hours, meaning beyond that standard staffing window that I shared earlier, to about 75 events a year. So if you've ever attended ACL or South by Southwest, which we'll talk about here shortly, we extend our hours to be able to facilitate ingress and egress appropriately and be able to manage those systems in real time. And we've had the luxury of working with our partners at INRIX to be able to not only prepare for those events and plan our signal adjustments, but as well as evaluate their efficacy from perhaps a weekend one to a weekend two and better improve our experience for ridership and the city. So moving specifically into the special events I'm talking about, I want to take a moment to reflect on a special event that we just had earlier this year, South by Southwest. So if you're not familiar with South by Southwest, it's an annual tech conference that lasts 10 days, usually in mid-March, all over the city of Austin. It started in the early 80s and it's just been ballooning ever since. It's quite an interesting event and a kind of different beast than working something like a UT football or ACL, in which case it is very standardized, when folks are coming in and when folks are leaving. And that South by is kind of known for having a lot of pop-up activity. So, you might have a pop-up Harry Styles in a small bar district that you didn't expect to. And so suddenly, you're having a large influx of folks moving to an area that you perhaps didn't necessarily plan for or is non-standard compared to a regular travel pattern. So we like to use this event as a great example and opportunity for us to not only kind of flex our muscles as far as how efficient we can make our traffic system, but how readily we can use our data sources to be able to improve our experience from week to week. What you're able to see here is, like I mentioned, there's a couple photos of both the tech side of the conference, which is normally in the front half of the week, to the more music-centric side of the conference, which is normally the second half of the week. But these are just some examples of what we call central commands. So we're telling a signal to run something different from its standardized time of day pattern, and we can command that not only to an intersection or perhaps a corridor, but we can do that to any part or subset of the town. So we can command all of the downtown core, for example, or all along Cesar Chavez, which is an east-west route in downtown, or things related to that. So using signal analytics, using our INRIX data, which is trajectory-based data provided by INRIX, which has a proliferation rate of anywhere, I think, from 5 to 10%. Sean will speak on it later in our presentation. We were able to decide how we're going to adjust our signal plans from weekend one, which was the first part of South by Southwest, to weekend two, which is the more music-centric side. So I've included some examples of how we were able to take data from weekend one, make a signal adjustment, and apply it to weekend two. So what we're looking at here is a cutout from Signal Analytics, and we're looking at IH 35 and 11. So right downtown, major inbound traffic and outbound traffic for folks coming into the event. And you'll notice that that northbound left on weekend one was around 1.9 minutes. So you'll see a level of service associated with every movement. And dark red is generally not something we like to see. It's a lot of delay. A lot of folks are turning into downtown to attend the event. So it was not terribly surprising that we were seeing a lot of delay in this movement. The red is indicative that it is not necessarily standard for the historical data that we're seeing. You know, generally we're not seeing that many folks trying to turn left into downtown for the PM peak. So we knew this was event related. So between weekend one, we made an adjustment and gave more time to that northbound left as it had from weekend one. So weekend two, when we were able to take that data point, we were able to save around 54 seconds in control delay for folks making that movement. Similarly, in a different part of town, we saw something very similar where a southbound left at 7th and Comal. So we're still downtown. We're still positive that this is event traffic. They were experiencing a delay of around 1.1 minutes. And after our adjustment, comparing weekend one to weekend two, we're able to save folks 34 seconds. Now, I want to take a moment and understand that not all of our data is in a black box, right? You know, data does not tell everything. Just because you made an improvement somewhere that you think, oh, well, this is, you know, signal operations 100%, we're going to be able to see that benefit pretty quickly. There is sometimes a little bit of a drawback. So 7th and 35. So this is also in that downtown core, folks going into the event, or in this case, moving from the west side of downtown to the east side of downtown. We made a signal adjustment that we thought would really help those folks out. And it turns out that it didn't exactly one-for-one benefit like we saw in our other areas. And this could be for a myriad of different reasons. In this particular instance, I believe there was a car crash or something in this area, and they had multiple lanes blocked on this intersection. So, you know, even though we made the adjustment in our minds that we expected to see some level of improvement, it's a nice reminder that you need to take into multiple different data feeds from multiple different sources to be able to have a true understanding of how you can better operate and maintain your traffic system. So we're all reporting to folks, and we all want to make sure that we can communicate our benefit not only to other engineers that perhaps have a clear understanding of how, you know, our traffic, ATSPM, and performance measures are calculated, but as well as to folks that might not necessarily be engineers and need to understand that. So this is a dashboard that we've built internally using Power BI. We are taking an internal spreadsheet that we kind of record all of our MMC actions, is what we call them, and we'll be able to calculate that into user savings. So we're taking an assumed delay, an assumed vehicular volume, multiplying that by road user costs, and it results in savings for the traveling public. So we're pretty excited that we're nearing $500,000 in benefit this year from not only responding to signal timing adjustments, using that fire data, social media feeds, and other crowdsourced data sources, but also, you know, being alerted to infrastructure repairs, perhaps a stuck detector or a stuck push button, as well as incident response like those crashes I was talking about. So very excited to talk about it, but all of this would not be possible without our partners at NRIX. And this is where I'll hand it over to Sean.
Thanks, Allyson. That was great. And hopefully you don't mind just passing through the slides here. Covered a lot of ground there. Crowdsourcing has been a great discussion point so far. Allyson, can you maybe go back one slide there? So as Allyson was talking about, that previous dashboard was great. They're taking the delay metrics that are pulled from NRIX signal analytics data to allow folks to be able to see movement by movement what's happening, as well as overall intersection delay, and providing that user cost from time savings. So the signal analytics package really is a web-based crowdsourced tool. There's a dashboard, there's intersection level data, there's corridor level data, and then there's some custom reporting that comes from our partner, the CAT Lab at Ritis, University of Maryland. Let's go to the next slide. And so our data is coming completely crowdsourced. It's probe data. It's vehicle to X, vehicle to the cloud. We're only using high frequency data. So there's a lot of different data sources for probe vehicle out there. We're taking only the highest frequency. So the data has to report in sub 5-second intervals for us to use it. We're making that determination because we want high fidelity information with which to understand stops, delay, travel time, some of the things I'll talk about, but no infrastructure is required for this crowdsourced data. It's just flowing from a map, and I'll show you what that looks like in a second. Let's go to the next slide. Thanks, Allyson. So you've all seen a time-space diagram. That's effectively what we're showing here. And as you click through the slides, what we basically do is put a box around every intersection across the entire country. So we have information at all of the signalized intersections that are in our map provider, which is the vast majority of the United States. This allows us to do fair comparisons between the intersections across the city of Austin or across county, city, states. But allows us to look at free flow travel time. So somebody that travels through the intersection without stopping. And then we can also look at those locations where people are slowing down, stopping. Those are arrivals on red because we assume people are acting rationally. And then we can also look at the speed on approach. And if somebody's stopping more than once before they make it through the intersection, we're labeling that as a split failure. So we're getting some pretty interesting metrics that are equivalent across intersections like at the city of Austin with this crowdsourced data. Let's go to the next slide. So some of the performance metrics that we pull out for the city of Austin and others, travel time, turn ratios, again, it's probe data, so it's not a count. It is a subset of the population, and Allyson's right, it depends on where you're at in the country. As to what that capture rate is. I will say that we did a national report card that looked at last fall to last spring, and we saw a 13% increase in our sample sizes. So the trajectory is definitely up with crowdsourced data for signal performance measures. We feel really confident about the ability to reflect larger movements for a single day. And then for our movements that maybe don't have quite as much volume, we can start stacking the data and looking at it over multiple days, multiple weeks, or even multiple months. So let's go to the next slide, Allyson. When we built this tool, we got input from agencies. This is actually a survey that was done related to professionals all across the country. What signal performance measures were people looking for and how were they going to use that data? And then we used this to help drive the product so that we built something that focused on those most highly, at least stated, things that people wanted, you know, percent arrival on green shown in the top right there. Travel time and travel time reliability right below it. And then to the left of that, we're looking at split failures. And then at the very bottom here, we've got vehicle delay, which is the case study that Allyson showed. All of this information is directly pulled from the vehicles, crowdsourced, and then we can use that data to infer when delay changes, when percent arrival on green changes, that something has changed in the network. That might be something that we know as an agency has happened. It's construction or a special event. We still may want to make adjustments to our timings based on that. But more often than not, as a user of this tool, when I was at the county, I would use those changes in delay as inferences that something's gone wrong. I would say that a good portion of the complaints that we got ended up being root caused and detector failures or communication failures or other signal infrastructure failures. So this is a way to use crowdsourced signal performance data to help us understand our network better and proactively find those problems quickly. Maybe the next slide, Allyson. So these are just a list of kind of the use cases for this crowdsourced type signal performance measures data, retiming, impacts, TISMO strategies, kind of prioritizing things. I talked a little bit about equipment failure, so I'm going to stop there. Next slide is our contact information, and I will look forward to the questions and discussion from the panel and the rest of the folks in the audience. Thanks for the time today, guys.